welcome back to another gosh darn episode of Explosions and Fire. How you doing? Today we're talking McDonald's, or as it's known in Australia here, Macca's. Macca's. You know, the burger chain with the burgers and the fries and that sort of thing. But we have to ask ourselves, is it flammable enough? And I'll be real with you here, I don't think it is. I'm honestly not satisfied with how flammable McDonald's is. So before we start making it more flammable, we need to understand just how flammable the raw McDonald's is. I've come up with a 12-point flammability scale from 0 to 11. It's completely made up. We get to assign how flammable an object is based on how well it burns, I guess. So, you know, a 0, it doesn't burn at all, whereas an 11 is it detonating. So we can track our improvements to see if we can move McDonald's overall up the flammability scale, which I've just invented. That's good, and now it feels like we're doing real science because I've put a number towards it, so this all seems really legit. On the food side, you've got the buns and the meat and the cheese and the chips and the nuggets and the filet-o-fish and the pickles and the sauce, etc. And on the non-food side, you've got stuff like the bag, the cup, the paper straws, the burger box, and of course the toy that comes in all Australian McDonald's meals. Oh, sick, it's Grimace. Fuck, I love Grimace. I love getting a Grimace. I love doing it. Fuck, Grimace, how good's Grimace? I mean, comment below how good Grimace is, right? How good's Grimace? Oh, fuck, I love Grimace. So it's not really surprising. A lot of the paper things are reasonably flammable, but a lot of the food really isn't that flammable. So I think there's a lot of room for improvements. Is McDonald's my favourite fast food? That is a very good question. Thanks for asking. Probably not. I reckon my favourite fast food is a Taco Bell Crunch Wrap. I have never been to a Taco Bell. I have never seen a Taco Bell, but the idea of a Crunch Wrap Supreme just sounds really good. I mean, I like wraps. I like the concept of crunch. Well, it's probably the best food ever. I wonder if there's a Taco Bell in Australia, isn't there? There's heaps of Taco Bells. There's one close by. I could drive there and back nearly in a day. Now, I don't think I've ever lived this close to a Taco Bell. That's fantastic. I feel like there's an obvious solution, which is just pouring a whole lot of oxidizer all over the food and then lighting it on fire. And that feels like cheating. We're not really making the food more flammable. I mean, sort of, but it does definitely just feel like cheating. So that's not what we're going to do. That doesn't really count. Yeah, see? Still goddamn delicious on the side. And the same thing goes, we're not just going to put a flammable fuel all over the McDonald's and then light it on fire and count that as increasing its flammability. What's up with that? Why would you suggest that? That's barbaric. This is a chemistry channel. The point of chemistry is not to be barbaric. The point of chemistry is to play God. I want to get into that food and manipulate it on the molecular level. There is an important second rule after the first, no cheating rule, which is not using any oxidizers or external flammable fuels, because that's obviously cheating. We want the food to somewhat resemble food after we're done with it, right? If we're making a burger more flammable, we need the end product to somewhat resemble a burger. It's very easy in chemistry to grind things up and then turn them into tars or sludges or slimes or weird precipitates. And I feel like if we just turn a burger into tar, even if it gets more flammable, that doesn't really count, right? So we can't dissolve the stuff in, a solvent. I wonder do you reckon a chicken nugget dissolves in dichloromethane? That's a thought I've just had. I reckon. Let's try it. Let's try it, right? dichloromethane has a slight yellow colour. It's picked up something, but the nuggets still look mostly fine. I actually thought they dissolved a little bit better than they did. Anyway, that has been a great use of my time. So my idea of how to improve the flammability of all of these items is through nitration. Now, there's lots of different reaction conditions for nitration, but basically you're trying to get a NO2 group onto the molecule, whether that's onto an oxygen or onto an aromatic substituent or just onto a carbon anywhere or even on another nitrogen. In terms of flammability, this is really good because it's just putting 2 oxygens into the structure. The nitrogens also help a little, I suppose, but mainly for burning, we're improving the oxygen balance of the food. Because a lot of this food and the packaging is made up of organic molecules with a lot of hydroxyl groups, the reaction conditions we're going with are quite cold. We're using concentrated sulfuric acid. So we can set up a nitration mix here. We've got some cold concentrated sulfuric acid, and we're adding a nitrate salt in there, which is going to generate our nitric acid. And then we can go about adding our packaging materials. So we've got our cotton, we've got our burger box, our straw, and we can run that through a very gentle nitration over a couple of hours. Wash it to get rid of the nitric acid, dry it out, and test its flammability. Ugh. Nice. And this is really cool because in a lot of circumstances it doesn't change its actual physical properties too much. It still feels like a napkin. So I mean, that wasn't too hard. We used our knowledge of chemistry and we drastically improved the flammability of the McDonald's packaging material. However, a problem arises when instead of packaging material, we try using the insides of a sentient creature. See, we're using concentrated sulfuric acid, and that doesn't really play very well with a lot of organic materials. Initially, not too much happens as the sulfuric acid starts to pull out the water that's residual in the nugget, and it will start to heat up. But as the sulfuric acid starts to get hot, it's able to break down the molecules in the nugget to pull water out of it, which heats up the sulfuric acid again, which continually breaks down the nugget, producing carbon and heating up the sulfuric acid until it starts boiling. And then we have boiling hot sulfuric acid, which will churn through our nugget and is even able to oxidize some of that carbon to carbon dioxide. And seeing as we're using concentrated sulfuric acid in our reaction mix, this is obviously not going to work. But what happens if we get the food really dry before the reaction mix? Now, I did have this belief that McDonald's food just wouldn't go off. It just doesn't go moldy because of all the preservatives they use or something like that. Which means if I wanted to dry it out, I could just leave it in the sun for an extended period of time and then just come back when it's all dry. But it absolutely doesn't work like that. I don't know whether Australian microbes are just built different, but the food got horrendously moldy. Biohazard level moldy. So a much better idea to dry out the McDonald's is with a food dehydrator. We'll buy some more Maccas, see which toy we get. Ah, Grimace. I love Grimace. I'm not putting him in the dehydrator though. Don't worry, I'm not going to put Grimace in the dehydrator. That's cruel, alright? Why would you suggest that? Okay, I'm not going to put Grimace in the dehydrator. So we divide up our cheeseburger into different parts, we put some fries in there, some nuggets, and we let it run for, 3 days or so until we get the stuff really nice and dry. Definitely worse. You know, the nuggets kind of have like this softness to them, which is gone.
Let's do it like an ASMR.
Tastes so miserable. The dehydration has sucked all the joy out of this chip. Seeing as we've taken a reasonable amount of water out of the food already, it's probably time for a flammability check. Has just dehydrating the food made it more flammable? I mean, yeah, a little bit. The fries are actually starting to get, somewhat flammable.
Getting that really nice burnt nugget smell.
Mmm. Now that our food is all nice and dry, we can go about nitrating it in a mix of nitric and sulfuric acid. I'm just going to start with the bread and the fries here in the nitration bath because they're mostly starch and sugars, I believe, so they should nitrate pretty well. The meat products have an extra issue, which we will get to later, but for now we'll just nitrate the bread and the fries. After 3 hours, we'll pull them out of the nitration bath and give them a wash in some ice cold water to wash off any residual acids. Then it gets a wash in some sodium bicarbonate solution, which tries to neutralize all the excess acids, but it goes quite badly. First of all, it does go a horrible yellow color, which is never what I want to see. The neutralization reaction releases a lot of gas, which breaks apart the bread really well. Before long, we don't have any nice pieces of bread anymore. It's just a lot of bread powder, but I did manage to salvage a few chunks out of it. We leave it to dry, initially over some calcium chloride, just to try and pull a lot of the moisture out, but when it looked like it wasn't really drying fully that way, we used a vacuum desiccator over our friend phosphorus pentoxide to try and really remove all the residual water. So after all that work and 2 weeks of drying, is it more flammable? I mean, not really. It's not very good at all, actually. My feeling is we didn't get rid of all the sulfuric acid, which means it never really dries properly, even over phosphorus pentoxide, but maybe the nitration reaction didn't even really work that well. We only ever really nitrated it right around the edges and didn't really get in all in there, you know, like we actually need to do. So I was thinking about this, how can we do this better? Because we need the food to stay more together, but it needs to be more porous so the reaction mix can kind of, you know, get in on in there. So what if, instead of using a food dehydrator to dehydrate the food, can we freeze dry the McDonald's?
Fuck you. Oh, I am getting frostbite. Oh, it's so light. That's so weird.
So that's Thought Emporium, who I convinced to freeze dry some McDonald's and ship it all the way here from Canada. Also, no negative comments because technically it's a desiccated meat product, so it's a McDonald's jerky, and jerky is allowed through Australian customs through the post. So, didn't actually violate any custom laws.
Oh, Lord.
The advantage of freeze drying is not only does the food keep its structural integrity very well, it is quite porous and very light and has very little moisture left in it. It's also possible to freeze dry the least flammable items at McDonald's, such as the tomato and the ice cream.
Ice cream for sure is what I'm excited about.
What is...
It is. I mean, it's chalky, but it's like a nice chalky. It's actually very good. It just tastes like an off nugget. A very off nugget.
I don't mind it.
Don't mind it? It's bad. There's like little bits of lettuce here.
Crunch. Oh, is that a pickle?
Is it pickle? Oh,
That slaps.
that's the highlight of it. This looks, I mean, it's like foam. I think we should eat our McDonald's hydrated, honestly.
Now that we have our freeze-dried McDonald's, we can set up another nitration bath, which I'm going to split into 4, just in case there's some issues with components of the McDonald's mix. Actually, speaking of issues, we really got to talk about the nitration of the meat now, don't we? That's what we got to do. We got to talk about the nitration of the meat. All right, I hate to break this to you, but McDonald's meat contains a component of fats and oils. Now, animal fats and oils are made up of triglycerides, which is a fatty acid on a glycerol backbone. And under acidic conditions, you can have a deesterification, so you can chuck off that fatty acid bit and just be left with the glycerol. And then you have your glycerol in your nitration mix, and it's going to turn into... It's quite flammable, but it is very explosive and quite sensitive. So how do we manage it in this situation? Well, I went to the best safety control I know. Denial. It'll be fine. Okay, back to our nitration bath. We've got our bread and our fries, our sort of starchy mixture in one. We've got our nugget in one. We've got a little bit of meat and cheese in one, which is kind of our like fat nitration bath. And then we've got one that's the tomato and the pickles and the lettuce. I'm not going to follow up on the lettuce. The lettuce just fucking died in the reaction mix, okay? I'm not going to make the lettuce flammable. It's It's not super ideal because all the freeze-dried stuff floats because the sulfuric acid is quite dense and the freeze-dried stuff is just full of air and we can't really make it sink. So we just keep them bobbing on the surface. Once my patience is up, we fish it out and put it in some ice water to clean off the acids and just have it sitting there for a little while like a little turd just sort of bobbing around. We really want to try and get all the acids out of the mixture at this step, but we do another wash with sodium hydroxide this time, just a very weak sodium hydroxide solution, just so there's no gas generation which seemed to rip apart all our freeze-dried and nitrated material. Then to help it dry, we'll give it a brief wash in methanol and then we'll set it up to dry. I think the worst ones are definitely the bread, which acts exactly like you would expect freeze-dried bread to act. It's just a big sponge for liquid. Even though they kept their shape pretty well, I had to absolutely flatten them out to try and soak up some of the liquid that was still inside of them because otherwise they just would not dry. So once again, we'll give this a week to dry and then we'll put it into our vacuum desiccator over some more phosphorus pentoxide. I'm also going to chuck in a little bit of ammonium bicarbonate just so that it maybe releases some ammonia which will react with the nitric acid and sulfuric acid that is potentially left to help the drying process. Actually, this is a very side point, but the food absolutely no longer smells like food. Before, even when it's freeze-dried, it smells like McDonald's. After the nitration bath, it smells like you'd expect a poison in a cartoon to smell. It's like a cartoon poison smell. This is poison now. That's how chemistry works. You take something, you do something else to it, it gets more poisonous. Oh, and also on the other side, the beaker from the meat and cheese nitration mixture was actually covered in a bit of an oily film on the outside. It could have just been the fats, but I'm not going to do it again, and definitely not at a larger scale. Don't do this. I mean, if you're thinking of doing this, what are you doing? Bro, just go to McDonald's, enjoy the food like a normal person with your friends, and enjoy the toy. There's nothing more to it. Oh, hell yeah. Another grimace. Hell yeah. Where were we? Oh, yes. Making the food more flammable. Okay, so is the food, after all our efforts, actually more flammable? Oh my God. Holy shit. It actually is. Whoa. Once again, I get to the end of all these videos and I don't know how to act because I kind of plan the video like it's not going to work and then it vaguely works. Something actually worked. I still think we have issues with both drying and penetration of the nitration mix, but we're keeping the food together and not grinding it up or turning it into a tar or slime or sludge. So we're going to have that issue, right? Here is our final assembled burger. Obviously, we have, bread on the bottom, followed by our meat and cheese. Slice of tomato there, beautiful. Pickle goes on the burger, followed by more bread. Undoubtedly a burger. So obviously all the components in our burger have been freeze-dried and then nitrated. Got our nitrated nugget here, nitro fries. We've got our nitrated bag. That's on a nitrated napkin. It just looks like an ordinary napkin, but it's definitely nitrated. And that is a normal cup, except the straw. That's a nitrated straw. It's kind of burger looking. I'm really stretching it here. So we made it more flammable. I mean, not by a huge amount, but we did. I would love to revisit this. So if you have any suggestions on how you would have gone about this or other reactions I could do to try and make a hamburger really flammable, I don't know why you would know this, but if you've got some ideas, I want to hear them. On my own, this is probably as good as I'm going to get it, but with your help, you bunch of psychos, I could probably do a lot better. Look, I got to say, I'm sick of this shit food though. Been eating so much McDonald's. I deserve some good food. I deserve something really good. Some sort of really good food. Hey, you hungry?
Yeah.
All right, let's go. I mean, what? We've done 3 hours now? Is it 3 hours?
It's 2.5.
2.5.
Cows.
Cows.
past 700 kilometres.
700.
Oh,
Oh Lord, that was
and
nearly our
nearly
last kilometre.
died.
There it is. There it is.
Cheers.
Yeah, cheers. All right. Now what?